In the last section, we talked about how a simple phrase could be handled, a spoken phrase containing a couple of nouns and a verb. Now let's go a step further and think about how a more complex sentence could be handled, still using the simple cortical model. The grey oval indicates that auditory attention is being paid to the one word, and the attention shifts in succession to each word in the sequence, meaning that auditory receptive fields are detected within each word in turn. We're going to continue to use this simple cortical model, although it has some known approximations. For example, in detail, the indirect activation process involves receptive field detections in the auditory area, having recommendation weights into the basal ganglia in favor of releases to the inferior temporal cortex. And if accepted, the behavior is implemented by the thalamus, and detections in the inferior temporal area can lead to releases to the visual areas. But for simplicity, we'll take all this for granted and leave it out of the description. So within the simple model, the first step is that the word neighbours is heard. Hearing the word directly activates auditory columns. These auditory columns indirectly activate a group of columns in the visual area that discriminates between objects. The indirect activity is maintained at a specific phase of frequency modulation. This column activity is prolonged, and the next word is heard. The word black directly activates auditory columns, and again there's indirect activation at a different phase of frequency modulation, and this time in the discriminates visual features area. The activity of this second population is prolonged, then auditory columns are activated by hearing the word dog. That indirectly activates a second population at a second phase of frequency modulation in the visual objects level. At this point, the outputs from the population corresponding with black in the discriminates visual features area are synchronized with the new dog population in the discriminates objects area, driving a somewhat shifted and enhanced population at the discriminates objects level that will correspond with, let's say, a black dog. Various receptive field detections within the structure of the word sequence and the presence of a pause recommend extinguishing the population at the discriminates features level and synchronization and release of the outputs of the two populations to the discriminates groups of objects area. In the discriminates groups area, a population of columns is therefore activated that's similar to the one that would have been activated if a neighbour's black dog had actually been seen. The activity in the groups of objects area is prolonged, but the populations in the visual objects area are extinguished. The next word is heard and directly activates auditory columns. The auditory columns, directly activated by hearing the word chased, have recommendation strengths in favor of indirect activation of a second population at the groups of objects level. Then, the two populations at the groups of objects level are maintained active at different modulation phases while the next word is heard. The word little directly activates auditory columns. The auditory columns indirectly activate columns in the discriminates visual features area. The activity of the visual features area is prolonged, and the activity in the groups of objects also continues to be prolonged, and the word cat is heard. Hearing the word cat results in activation of a population of columns in the visual objects area. Activity in the visual features area corresponding with little is now released to the discriminates objects area, where it somewhat shifts the existing cat population. The activity of this little cat population is prolonged, and then hearing the word up results in activation of a population in visual features. The activity is prolonged, the next word is heard, and the word tree results in activation of a column population in the discriminates visual objects area at a different phase of frequency modulation from the existing population. The outputs from the population corresponding with up in the visual features area are brought into the modulation phase of the population corresponding with tree in the discriminates objects area. That drives a shift in the tree population. So at this point, there's a population in the visual objects area that corresponds with little cat, which is a kind of average of past experiences in which little cats have been seen. There's a second population corresponding with up tree. Then there's a population in the discriminates groups area corresponding with chased, and another population corresponding with neighbor's black dog. Now, the outputs from the populations in visual objects are synchronized and released to the groups of objects area, where they activate a third population of columns, again at a different phase of frequency modulation from the existing populations. So now there's 3 populations active at the groups of objects level, corresponding with neighbor's black dog, chased, and little cat up tree. These 3 populations are released to the group of groups area, and there they drive an activation of a population that approximates to the one that would have been activated if you'd actually seen a neighbor's black dog chase a little cat up a tree. So the sequence of words has driven the creation of a pattern of cortical activation similar to the one that would have been created by sensory experience of the situation described by the words, but as always, without the active columns close to raw sensory input. So the processing of speech involves sequences of internal brain behaviors: attention, indirect activation, activity prolongation, activity synchronization, in very specific orders. And speech requires a portfolio of these different behavior sequences, and each sequence will often be used. So the sequences can become encoded in the cerebellum and be executed much faster.